Good morning, students. Today we are going to read about free fall in the topic of kinematics in the subject of physics O levels. So concentrate yourself. This is technical topic. There are some technical points which you have to understand. So we are going to start. Concentrate yourself now. When an object which is held at a distance from the Earth's surface is released, it will fall towards the Earth. This is due to the force of the gravity acting on it. If there is no air resistance, all objects, irrespective of the mass or shape, fall with the same constant acceleration. So this is one of the very important point. If we remove the air resistance, irrespective of the shape or weight, all the bodies will fall with the same constant acceleration. This acceleration is known as the acceleration of the free fall or acceleration due to gravity. The normal symbol used for this acceleration is small g. Close to the Earth's surface, the value of the g is constant, and for calculation purposes, the value is assumed to be 10 meter per second square. And here are two graphs that are very important as far as your papers are concerned. Paper number 1 particularly, the paper which is MCQ's paper. Figure below shows the displacement time graph and the velocity time graph for an object falling under gravity from rest. So displacement time graph is of this form, and velocity time graph of free falling body is of this form. So you have to remember them because these graphs come in the paper and you are required which type of the graph is this, so you have to take. And other very important thing, it was Galileo who discovered that a heavy object will not fall faster than light object. So he is the person who was responsible for discovering this concept. And anyways, the next topic is, here is an experiment to show the motion of the body in a uniform gravitational field without air resistance. So look now, we will prove now whatever the shape of the body or the weight is, if air resistance is removed, they will fall with constant acceleration. So this is the experiment. This is an experiment which is related to your paper number 4, alternate to practical. So very important practical. This is from kinematics. So we are reading this topic in the same lecture. So concentrate now. Place a feather and a coin in a perspex tube figure below. So look now. Here is a perspex tube and we have placed a coin and a feather in the tube. So look now. Invert the tube and observe which of the two falls faster, which will be definitely coin, because if there is air resistance, so in the starting there will be air resistance. If we invert the tube and observe which one will fall faster, so definitely it will be coin. So now proceed. Look now, connect the tube to the vacuum pump and remove the air in the tube. Okay, now there is no air resistance because we have removed all the air from the tube. Invert the tube again and repeat the observation. What can you conclude about the effect of the air on the rate at which the objects fall? The feather and the coin will now come to the bottom at the same time. This shows that when air resistance is negligible, all objects fall freely and have the same acceleration, that is acceleration due to gravity. An important note for you is, although the acceleration due to gravity is considered constant, it tends to vary slightly over the Earth because Earth is not a regular sphere. It bulges at the corners. So look now, very slightly over the Earth. Since the planet is not a perfect sphere, the value of g is generally taken to be 9.81 meter per second square, often approximated to 10. However, so this is the point to understand. However, at the North Pole, the value may be as high as 9.84 instead of 9.81. So, higher value at the North Pole and lesser value at the equator as low as 9.78, because Earth is not a regular sphere. It bulges at the corners. Okay, the next topic is very important, skydiving, that is terminal velocity. So concentrate now. This is a technical topic which you have to understand the technicalities which involve in the terminal velocity. So look now, when a skydiver leaps from an aeroplane, the diver's weight pulls him her down. The air resistance is small compared to the weight as she start to fall, and so the diver accelerate. So look now, in the beginning, so here is a figure. In the beginning, when he leap from the plane into the air, the body weight is greater than the air resistance. Look now, the smaller arrow stands for smaller amount, the greater arrow stands for greater amount. So weight is greater, air resistance is smaller, so the body will accelerate. So accelerate. Look now further, air resistance acting on moving object increases as the velocity of the object increases. So as the body's velocity will increase, air resistance will also be increased with it. And there will come a time when air resistance also depends on the shape of the object. An object that is streamlined. So these are the conditions of the air resistance. So air resistance depends on the shape of the object. An object that is streamlined experience less air resistance compared to an object that is not. So if the diver jump head down, so that will be streamlined, so the body will accelerate more speedily. But if he jump into the air like in horizontal position, the more air resistance will be applied to the body and acceleration will be lesser. So body shape matters as far as air resistance is concerned. So look now, eventually the force of the air resistance balances the force pulling the diver towards the ground, and acceleration of the object decreases until it is zero. So acceleration becomes zero eventually because the air resistance becomes greater as the speed gets more. But it doesn't mean that if the acceleration is zero, actually the body fall with a constant acceleration then. So look now, the figure B. There will come a point when the air resistance will balance the weight and body will fall steadily at terminal velocity. So there will be a constant velocity, that will be a terminal velocity. So body will fall with a constant velocity. So further, when the skydiver opens the parachute, the air resistance greatly increases. Because the parachute open, there will be a greater surface which will resist the air, so there will be more air resistance now as compared to the body. So now body's weight is lesser as compared to the air resistance. So body will go down very slowly now. But after some time again, the air resistance will balance the body weight again and acceleration will become again zero. But it doesn't mean again that body is not moving. So body will fall with even lesser velocity, very lesser velocity. That velocity will again be called terminal velocity. So look now, the parachute is open, so there is a greater surface, air resistance is more as compared to weight, so the body's acceleration will get more or less. So but after some time the air resistance will balance the body weight again, and the body will gain a constant velocity again that will be much lesser than as of the previous case. So that will be called again a terminal velocity. So body slows down. This slows down the skydiver to a new slower terminal velocity, so he or she can make a safe landing. When an object is falling with terminal velocity, air resistance acting on it is equal to its weight. So concentrate now. We are going to show you an example and a video that will make your concepts more clear.
When a skydiver jumps out of a plane at 3,000 meters, her speed goes through some big changes. So what's happening to the forces as you fall through the air? The force of gravity is always trying to pull us towards the Earth. Before the skydiver jumps, the floor of the plane provides a counterforce, which balances the downward force of gravity, right up until the moment she steps out. Gravity immediately pulls her towards the ground, and she starts to accelerate downwards. But air resistance is acting in the opposite direction. The faster she falls, the greater the air resistance. Eventually, the upward force of the air equals the downward force of gravity. When forces are balanced, the speed remains constant. That doesn't mean she stopped falling. It means she stopped accelerating. She's still doing a steady 55 meters per second, and hitting the ground at this speed isn't a good idea. To slow down, the upward force needs to be greater than the downward force. When the parachutes open, air resistance suddenly becomes much greater than gravity. The forces are no longer balanced, and this changes her speed. She slows down. Because she's slowing down, air resistance decreases until it balances gravity again, and she reaches a much slower constant speed. Approaching the ground at 5 meters per second is a much better idea. As she hits the ground, there's a thumping great counterforce from the Earth, which decelerates her very quickly.
So that was the video. I hope so. That helped you a lot in understanding the concept of the terminal velocity. So now here is a graph of body in free fall in the atmosphere. If there is no air resistance, this will be the speed time graph. And if there is air resistance, after some time, the air is because of the air resistance, terminal velocity will be gained. So this will be the speed time graph in the presence of the air resistance. Okay, this is the velocity time graph for the terminal velocity, because first the velocity will be increased and gradually will be decreased, and after that a constant velocity will be gained, that will be called terminal velocity. And here is the acceleration time graph, because at first the acceleration will be increased and after that the acceleration will be decreased. Note that air resistance is a frictional force. It has the following characteristics. It always opposes the motion of the moving objects. It increases with the speed of the object. It increases with the surface area or size of the object. It increases with the density of the air. So more the density, more will be the frictional force. Less the density, less will be the frictional force. Terminal velocity. When an object falls freely in a uniform gravitational field, it accelerates until air resistance is equal to the pull of the gravity. It then continues to fall at a constant velocity, which is also known as terminal velocity. So here is our example now. A skydiver reaches a terminal velocity in 10 seconds and falls for another 2 seconds before parachute opens. Does he gain more speed during the first second of fall or the 9th second? So definitely in the beginning, speed will be greater, and gradually the speed will be like up in the 9th second. So look now, the acceleration of the skydiver decreases as his speed increases. Thus, the gain in speed is greater during the first second than during the 9th second. So this is the reason, because the acceleration gradually decreases. So gain in the gain in the speed in the first second, gain in the velocity in the first second is greater than the gain in the speed in the 9th second. B part, does he fall a greater distance during the first second of fall or during the 11th second? Explain your answer. So look now, the terminal velocity with which the skydiver is falling during the 11th second is greater than the average velocity during the first second. Thus, the distance he falls during the 11th second is greater than the distance he falls during the first second. Okay, here is another experiment that is actually related to the paper number 4 of your physics subject, because this is the topic which is included in the kinematics topic. So that's why we are reading the topic here. But this is a topic that will come in paper number 4 of physics in in alternate to practical paper. So look now, measuring G by free fall. An experiment to find the value of G is shown in the figure. So here is a figure. Here is an electromagnet with which ball bearing is attached. So when we will switch, when we will on the switch control unit, the ball will drop, and when it will hit the, okay, after just leaving the magnet, this timer will be on, and when this ball will hit the magnet, this portion, that is gate switch called. So when the ball will hit the gate switch, the timer will off. So look now, what is the procedure? The principle of the experiment is to measure accurately the time it takes for a ball to fall through a known height. The acceleration of the ball is then calculated using one of the equation of the motion. So look now, if the ball only falls a meter or so, it does not gain enough speed for air resistance to affect its acceleration significantly. So this is some explanation about the experiment. So from here, the experiment now starts. The electronic timer is automatically switched on when power to the electromagnet is cut. So when we will switch this switch on the control unit, the electromagnet will be cut. So automatically the timer will get on. At this instant, the ball starts to fall. the electronic timer is switched off when the ball strikes the gate switch. So when the ball will hit the gate switch, it means bottom, the timer will be switched off. Okay, in this case, U is the U is 0 because the ball falls from rest, because the starting position was at rest. That's why the initial velocity is 0. A is the acceleration of the free fall. S is the height fallen, that is h. T is the time recorded on the timer display. And S is equal to ut plus half at square. That is the equation that will be used. Because initial velocity is 0, so this factor will get 0. So S is equal to 1 by 2 at square will be there. And A is actually free fall. So that's why G is used in place of A. From here, G will come to the left side. And okay, this 2 will be multiplied with h, and t square will come into the denominator of h. So 2h over t square is the equation that will be obtained from this equation, original equation. From this, g can be calculated because h is there, that can be measured, and time is also there, that is recorded. So put the values into the formula, you will get the value of the g. Here is a question. A heavy ball is dropped from a height of 20 meters. Find first part the velocity just before striking the ground, and second part the time to reach the ground. Answers are here. And other question is here. A ball is thrown vertically upward with an initial velocity of 15 meters per second. Calculate the time to reach the greatest height. Second part, the magnitude of this height. We will solve this question on the board now. So come. So the data for the first question was a body is dropped from a height of 20 meters. So height is 20 meters, and because it is dropped from a height, so it means the initial velocity will be 0. Requirement is find its velocity just before hitting the ground. It means final velocity is required, and the time during the process is also required. So look now, because this is the thing, so in this case also acceleration due to gravity will also be involved. That is 9.8 meter per second square. So use the formula h is equal to ut plus half gt square. So this is the equation that will be used. This factor will be 0 because u is 0. So h, that is 20, and 1 by 2 into g, that is 9.8, and t is the requirement. So from here, just cross multiply the values. 2 will go to the numerator and 9.8 will go to the denominator, and solve it on the calculator. You will get the answer of t. Now, another equation is used, that is v square minus u square is equal to 2gt. This is another equation. So v's value is the requirement, u is 0, that's why this will be finished, and 2 into g is 9.8, and t that you have find out in the previous part, that will be put here. Solve it on the calculator, taking the square root will give you the answer. Unit will be meter per second. So the equation will be used to gh is equal to v square minus u square. Now put the values into the formula. G is minus 9.8, h is the requirement, v is 0, minus u is 15. So minus 225 will be equal to minus, multiply it on the calculator. So this minus will be cancelled, and this number will go to the denominator. Solve it on the calculator. That will give you the height. and unit will be meters. Okay, now T is the requirement. Now use another formula, that is V is equal to U plus GT. Now put the values into the formula. V is 0, U is 15, G is minus 9.5, and time is the requirement. So this is the minus factor that will come to the left side and will become positive. So 9.8 T will be equal to 15. Solve it on the calculator, you will get the answer of T, that will be in seconds. So this is the answer.